My name is Morgan Roman. Hi. They work with me. This is about how to prevent developers from doing bad things with your existing framework and essentially stopping them from shooting themselves in the foot, aka I call it banning Footguns. So quickly about me, I work on the application security team. I work at DocuSign. I have two others standing over there. And I want to give special thanks to a couple people who helped with building out this process. And to ultimately decide what led to all this, we were tired of playing whack-a-mole with bugs, and that's why you have me right there playing whack-a-mole at RSA at some vendor booth. So, wanted to introduce that, and I want to make one thing very, very clear. I'm going to use examples with lots of weird little frameworks and libraries. This is a strategy. It's not particular to any library, and you can use this in whatever. So if this example I will show you will be in .NET, you can totally use it in like a Rails app or something like that. And also, if something confuses you, and you just want to ask a question right away, I'm actually totally open to just someone raising their hand and yelling it out, because it's kind of fun. All right, so let me get to the very simple idea, the whole principle behind this all. And it's basically this. You have A and B. The developer, or really anyone, wants to get from A to B. Anyone know how you get from A to B? Straight line. That's it. Developer will always take the easy way, the straight line. The issue and the entire crux of this presentation and this idea is this. This is the secure way. You have to do validation, you have to do encoding, you have to do lots of logging, you have to figure out what's going on behind the scenes, right? You have the secure way and the easy way, and they are not the same. And that is the entire principle, and the whole goal is the following. To make the secure way the easy way, because the developer doesn't, I mean, they might care about the secure way, but ultimately they will always just take the easy way to be able to ship faster. So I want to nail this in really well. This is bad. This is good, bad, good. We all got this? All right, so this is great, right? And this is like our ideal, and I'm just kind of like, here's the castle in the sky. So the developers will do whatever is simplest, right? And if it's the simplest, it's a lot easier to train, and you won't get in anyone's way. They won't have to make this tough decision like this guy. So I also want to mention that I'm not really reinventing the wheel. I'm sorry, I'm not inventing the wheel here. I'm just reusing something that's already been done. And so I want to go through a handful of existing examples on what has already been done to do this exact same process. So let's go into that just a little bit. The first one is how to reduce XSS, right? So there's a lot of frameworks out there, React, Angular, whatever. And by the way, I will have a lot of code in this presentation. They're just going to be little snippets like this. But if you want to take a minute to like take it in, just let me know if I'm going a little fast. But essentially, React says, okay, instead of interpolating HTML or whatever user input inside the thing, by default, we will just encode whatever variables that you put into JSX. But if you really absolutely need to, and you can see on the second line, have some dangerous HTML, and then you get HTML in the page, which is the essence of cross-site scripting, is when one user can put HTML on the page that doesn't come from the website itself and is able to take over another user's page. Then what you get is hey, this is dangerous. Don't do this. You scare them. This is something Tanya talked about, and I quite liked. I think it was Clint who did like, what was it, unsafe cryptography, MD5 hash or something like that, which I absolutely loved. But essentially, the same concept is right here. Developers will usually just not use this because it's like, oh, it looks dangerous, right? And it's not the default way. So let's talk about string concatenation, aka SQL injection. So SQL injection basically is just when you have a nice string that you're going to send into SQL to execute a SQL command, and then you just so happen to have some user-controlled parameter in it, and then somebody, they're a real jerk, and they just go ahead and put something horrible in there like, I don't know, that, and then dump the whole database. Not the best thing in the world, but as it turns out, there's a thing called ORMs, which is object relational mappers, and they usually just let you do most SQL commands without having you do dynamic SQL whatsoever, and have, basically handles all those situations. So this is the exact same command on the second line, which is just filter by, the name, whatever the user-controlled variable is. But I want to point out with this, in both these cases, the developers just wanted to query the database. They didn't really want to shoot themselves in the foot. They were just trying to do their jobs. So, but we've already made it a lot safer just by introducing an ORM by having it go on this filter rather than dynamic SQL. You just ruled out a lot of SQL injection. All right, let's talk about XXC in .NET. So by default, in previous versions of .NET, they would allow you to get this bug called XXC, which is essentially you define a variable in the DTD, the document type definitions, and that variable can access places on the file system, do all sorts of nasty things, explode the file to be massive, a lot of nasty stuff, right? And then to turn it off, you had to say, prohibit this thing to true, but by default, it was just totally allowed because it was in the XML specification. Honestly, the only people that ever used this were hackers. So, and I enjoyed it. I find a lot of findings with this. But nowadays, since by default, .NET just says, all right, this is prohibited, and you have to turn it back on, then developers do it the safe way because it's on by default. So you can just see this. It reads from the file system right there, and it'll evaluate it. But I want to emphasize one more time, the developers just wanted to parse XML. They did not want to shoot themselves in the foot. So how do we do this? How do we make the easy way the secure way? So we've seen some examples that have been done before, but obviously not all your problems have been solved. Otherwise, we wouldn't be talking here, right? So I have a 4-step process that I just follow, and I do this. So basically, I find the bad pattern, right? I make sure that the bad pattern is just something I see a lot. So if I see a lot of cross-site scripting in a site, or I see a lot of RDOS in a site, for example, for all sorts of reasons, I'll just find that, and then I'll make the safe pattern the default one. So find a way of writing a wrapper class, and I'll show you exactly how to do this. And then I'll even show you how to train the developers in the most efficient way. And then a really quick way to build some tools to enforce these new rules, because you don't want to just make a rule and then you can't do anything about it if someone breaks it. So let's talk about an example. RDOS. This is Regex denial of service. To explain what that is, essentially, if you have an inefficient regex or a user-controlled regex that is inefficient, you will basically open yourself up to saying, okay, this can be resolved in non-constant time. It's basically having a for loop and a for loop. So you have O of n squared for those who have taken computer science courses. And the safe way is you just wrap it in a timeout. That's all it is. So the developer has to remember every time they use regex to include that little time span from seconds, right? Do they always remember? Does anyone think they will always remember? You. All right. I'll talk to you later. But they have to remember that, and that's not the best thing. So here's some code to just make it safe by default. By the way, I kind of sanitize it so it'd be a lot shorter, but essentially, you don't really need to know everything that's going on here. Ultimately, I recommend you just have one of your AppSec engineers or an engineer write this if you're not the most technical person. But ultimately, the only thing is this default timeout is 1 second. Now, you can make it 2 seconds. It doesn't really matter. It's just that there is a timeout, and that's what makes it safe by default. And then down below on the couple other lines, I just had this mySafeRegex class inherit from the rest of the base regex class, and that's it. Any questions about this before I move on? Cool. So here's the sample training. Now you can take a picture of this, but I'm going to give you an even better slide to take a picture of, which will actually have the template, right? And you just have basically 2 sentences explaining why this is bad, what you should do instead, and then the examples below. And if you notice, the examples below are very short, very sweet. It says what they shouldn't do and what they should do, and they look about the same length, so it doesn't look that much harder for the developer. So here's actually the format. Take a picture of this slide, because it's a good one, right? If you use the bad way, the bad thing will happen. Instead, use the good way since it stops the bad thing. Do not do this instead. You basically have the entire template for most developer training, right? If you have a better idea, go ahead and do it. I found this extremely effective and just, hey, one and done. And I'll break this down a little bit. So I really recommend you don't include security lingo. So while I can just go here, yeah, there's XXC everywhere, right? And people here will get me, right? But developers, that would take a long time to explain, and they can just say, oh, you could write to the file system. That's bad, right? And you can talk about that, and that way they get it right away. Also, show the example how they intend to do it, right, before you show them the right way. Now, you may disagree with this, but I quite like this, and I've seen it be very effective. And if you really want, you can include details about OWASP. So how often or when should you train the developers? What I found a lot of success for is when the developer gets access to the project or repository. Because at that point, they're usually very excited. They want to put in their first commit. And you say, OK, here are the rules. Welcome, right? And then on any sort of reasonable cadence, so once a year or once every 6 months, whatever you find is appropriate for where you work, retrain for their specific department. So if they're working on a Ruby project, don't give them the .NET training. Plain and simple, right? It's just not relevant to them. And this way, if you keep remembering to do this, you're not this security guard because, well, he doesn't look too effective. And in fact, we can do this in an automatic way. So here's code analysis for Regex denial of service. And I'm a huge fan of a thing called DevSecCon. It's made by Microsoft. It's free. Basically, it's grep and with some JSON configuration files. And I can break it down how it all works, but ultimately, you just look for a pattern like that. Now, that's about 80%, and that's all you need. And if you really want to go more in depth in a more complex way, you can just use something like Roslyn or any other static analysis tool. And this little code snippet right here just gets you the type for the whatever type that the class that you're looking at. So you can ban classes. All right, this is a JSON file. It looks painful to read. I'm going to break it down for you. But this is the regex class rule, very similar to what I use for DevSecCon. Basically, you start with a very simple rule. It's just new regex, and then I had to do a breakout for the parentheses. Very, very simple. It's very important that you have a clear description, right? And then maybe even link to some documentation. If a developer ever sees this, you might look through these first, but if you add it to maybe your CI/CD pipeline, you want to make sure that it's developer friendly. They know what to do. They know what to use instead, right? So right there it says, please use my safe regex class to generate this rather than the standard regex library. And then my optional thing, and this is one of the things I like about DevSecCon, is you can have exclusions, and they're really simple, and it's very powerful. All right. Oh, you were taking a picture. I saw that. You good? Okay. I don't want to interrupt anybody. So when should you do this, right? So while the developer is coding in the IDE is great. I work at a company where people use lots of different development tools and work on lots of different projects. So it's a bit difficult to do, and I couldn't really get adoption. So instead, I found out the developers are very open to feedback during pull requests. So basically, we include this as part of the CI/CD pipeline right at that point when developers are most open to hearing for suggestions. And also, I recommend doing on your own cadence, like if you say once a month, once a week, whatever you choose for the entire code base. That way you can catch anything that previous stuff didn't find. And this place, of course, the target is the security team. So we have made it very easy to stop regex denial service in your entire code base. All we did was find the bad pattern, make it the safe pattern, the default one, and then build tools to enforce these rules. Easy. Let's talk about XXC. So here's some code. Basically, we have the SAST parser. Now, I'm not picking on them for any particular reason other than they just showed up. But they're used in Java, and you get this same XXC problem. So what you can do is simply inherit, make your own safe, SAST parser, and I recommend doing it the exact same way as they do. So they use a factory method, so I just say, all right, we're going to use the factory method as well. And then I just say, do this, and you make it safe by default. And this way, the developer doesn't have to remember that, because I won't remember that crazy set feature URL thing. And then you have the training. This follows the same format as the slide I talked about that had that format. Essentially, you just want to have something like, OK, don't use SAST parser. the bad thing will happen, and then use MySafe XML parser factory, and then it blocks the attacker from doing these kind of attacks. And then you have a very clear example, what's safe and what's unsafe. And then voila, here is your static analysis. Simple. Have the pattern. Once again, it's meant to be about 80% good, but then again, it's just a quick line of regex right there. So you get it done very fast. And then, once again, I want to emphasize having a good description, good recommendation is vital for good communication. This one I went through very fast. So are there any questions about this one? Cool, you all get it. Very nice. All right, so we made it easy to stop XXC. We followed these 4 steps, and we just solved that across your entire code base. Congratulations. Now you just have to do the work. All right, let's talk about another bug. I like to call this one a fun one. Imagine you get an email like this. Anyone want to tell me what's fishy? Yep, you're going to get rerouted. Somebigbank.com redirect someevilphishing-site.com. And you know, you got to stop Mr. Robot from hacking you by giving him your username and password, obviously. So this is an open redirect. Essentially, you have a site that looks like it's legitimate, but then it'll redirect you to somewhere evil, and then they phish people. So you trick users, and even then, actually, you can get cross-site scripting if the payload is this, just this little JavaScript colon, whatever script you want. And we often recommend people to use whitelists, and then we often get stuff like this. So once again, audience participation. Let's play Spot the Bug. Anyone want to tell me what's wrong with this? You're smiling, so you know.
Well, it's looking for the website, which is in there, but it's not going to find the redirect.
Sorry, I can't hear.
It'll only fail if you're going to the wrong website.
Yeah, that's a good one. You're all right, but that's a fun one. The dot. He said that the dot is a wildcard character, any character you want. So it could be my safe website b com, and then whatever else you want in your URL. What else is bad? Anyone else want to tell me what's bad? Yes.
Are the ends of your regex being terminated?
Clearly not. Well done. All right. Yeah, that's the bad part. And then here are some things that will get totally past this whitelist. And by the way, this comes from a real example I've looked at before, and I asked, hey, please fix this. And then I get whitelists like this, and I'm like, yeah, I can break around that really fast. They don't check the protocol, right? So you can just, okay, cool. Put JavaScript alert. They don't understand that the dots are wildcards, and they don't check for if it's a domain or subdomain, so the string is terminated or not. Yeah. Oh, I'm sorry. That's hard to read. I should fix that. But my safe website xcom.evilwebsite.com. So bad subdomain, but it still validates the regex. Then evilsite.com, and then in the query string, so $foo equals mysafewebsite.com. Sorry for making this hard to read. And then the last one I give as an example is JavaScript :alert, and then mysafewebsite.com, because it would just totally validate the regex right there. Sorry, any other questions about this slide or this idea? Cool. So if you rely on the developer to always build this, they might often make mistakes because they aren't thinking about crazy breakouts. If you're the AppSec engineer, you're the person who breaks things. They're the people that make things. So oftentimes, now I'm going to show you the code for this one because it actually gets kind of annoyingly complex. So I'll just explain it. You make a safe redirect function or class, depending what you decide. And you just have an internal redirect method that blocks all non-HTTPS protocols. Why do you need a redirect to an FTP site? Well, you might, but if you really need to, you can add that special case in there, and then only allows redirects to your site. You can kind of assume these are safe. And this is great because you rule out a huge amount of them because, okay, you're redirecting to a site you own, and it's definitely not going to have JavaScript in it. Great. But then you can also add this external redirect for the times you do need to redirect to external sites. And you can set this up to require a whitelist as part of the parameters. And if the, if the developer puts in like an empty list, you can pick that up with static analysis fairly quickly. So let's talk about some really basic rules that we can write and essentially grep for with DevSecCon. Like I said, I'm a fan of this tool, but you can use whatever tool that suits you, right? You have this pattern. So fairly simple, find this redirect. It's kind of one of those things you write and never read because you can see all those lovely question marks and backslashes and stuff. And then you have sort of conditions that can say it's totally safe if you're using safe redirect. And then I want to emphasize, only aim for about 80%. You're never going to get these perfect, but if you aim to make it good, you can get there pretty well. And then you also have other rules, and you can add things like, oh, if it's external redirect, then set it as kind of a low priority for us to go take a look and make sure that the whitelist is good, right? So you have high priority rules and then low priority rules, because things that are definitely, hey, you're not following the rules here, or the ones that are like, you're probably doing the right thing, let's just double check. Okay, let's talk about another bug, the dangers of server-side request forgery. Basically, if you can call one server and get it to talk to any other server, so basically the server that you're talking to and you're able to get through the firewall in this case, is able to call other servers inside the data center, and that variable is user controlled, then you can just bypass the firewall because you can say, well, this server is on the internal network. Voila. Fairly useful. You can get past a lot of IP whitelisting. It's a great and powerful bug. And, it's kind of scary. So, what could you do with server-side request forgery? Once again, audience participation. For those of you who know, tell me what you think you can do with this. Just shout it out.
Call unauthenticated internal APIs and get your system down.
Yep. What's another one? Oh, sorry. I should say that because he doesn't have a microphone. Call internal IPs, and then use that to take down your system. You got one? Sorry? Yeah, metadata endpoints. Listen to those and get some private information, exfiltrate that. I like that one. So I don't have that as an example for the answer, so. All right, I'm just going to give it to you. So you get past the firewall and you call internal IPs. You can call external servers with very long responses, and this is a good way to have a denial of service attack because the server will take a very long time to parse it. You can do a file read, as it turns out. That's fun. And you can do a file write. And what happens when you overwrite the default.html in an IIS server? This is kind of obscure knowledge. Anyone know? Basically, take the site down. And you do that with one request. It's quite fun. Got in trouble once. Not going to talk about that. Okay, so sometimes you actually do have to make web calls, right? This is a feature, and I have this horrifying acronym right there, SSRF AAAS. So it's horrible, but it's something that a lot of applications do have to do, like they have a webhook. But you can make it a lot safer and just say, hey, don't use the standard HTTP request library. Use our safe wrapper class that blocks internal IPs, have a built-in timeout, blocks calls to the file system, or can limit certain things. So it's like if it's doing an internal IP call and you're normally blocking that, that's a great thing to log because that can usually pick up a lot of hackers because who else is doing that? And you have the safe version, make sure it inherits all the base abilities of your standard web client library. Okay, we're going to go over all these steps one more time because I want to hammer it in and hammer how you make the secure way and the easy way the same thing. So you look for the bad pattern, and what I like to do is I look for a common sort of sink, if you think about it. So everything boils down to one thing. So if you're looking for SQL injection, everything really boils down to dynamic SQL. Now there are other ways, but everything really boils down to one thing in particular. And if I see that, I'm like, oh, I can abstract that pattern and make it safer. So 3 examples that we went through. In this case, to do a regex denial of service, it has to reach a regular expression. XXE requires that you parse XML. You can't do XXE with JSON. I hope you can't. And open redirects require someplace redirecting. That's how you find this, right? You find these sort of problems right there. And then you make the safe pattern the default one. So we did this one for regex denial of service, but you have your safe regex, or my safe regex in this case, and it has a default timeout. You have a coder do this once, right? You might have to maintain this, but it's worth maintaining. And then finally, you should train the developers to use safe pattern. If you haven't taken a picture of this, it's super valuable, and it's like my go-to because I don't like to write a lot of things. But I do like having a template and just have ad-libs and voila, done, right? So this is my favorite thing. And then always include an example because otherwise they won't get it. And build tools to enforce the rules. You don't have to use the same tools that I recommended. There are a lot of good stuff out there. Use whatever that you like and it's easy for you to integrate with your system. I'm just a fan because I know how to write regex and most people know how to edit the regex and it's fairly easy and I just have a super grep, right? And then make sure that it's only about 80% effective because otherwise you'll be spending hours and hours trying to fix it. So finally, go back to the main things, find the bad pattern, make a safe pattern, train the developers to use the safe pattern, and build tools to enforce these rules. So that way you don't always have to keep watching. And you ultimately make the secure way the easy way. All right, thank you all. Any questions? Cool. I assume you all learned everything. Oh, sorry.
Hey, first of all, I love this approach. Seen it in a bunch of organizations. It seems like one of the highest leverage things you can do, period, in security, so I love it. And I'm curious.
He thinks it's great, by the way.
Yeah, I think it's great. Are there any bug classes you feel like this is not a good approach for?
I have not had the best, well, no. Here's an example of where I've seen it work really well in the same bug class and then really badly on a different project. So authorization issues. So in one project, basically all authorization went through one class. So I just looked for every controller that didn't use that class. And it was like, well, they did this for me. Like, this is easy. But then projects where authorization was like, weird layers and layers of calls, like I just couldn't use this. I couldn't find a common sync. That's the main thing that makes this useful or not, is if you can find a common sync or a common point where the bug happens, then you could probably use this, but if you can't, it's just not applicable. Cool. Does that answer it pretty well? What coping, so he asked, what coping techniques do I do that I have for working with organizations with thousands of code bases? Well, I kind of work at one, as you guys know. We have a lot of code bases and a lot of acquisitions. The main thing is I can't always hook into their CI/CD pipelines, and oftentimes it's going to be in a completely different language I've never seen before, which is annoying. But if I have seen it before, I usually just have my rules, and I can just run them again because that's what you can do with DevSecCon. And I have it saved in a JSON file, which is nice. So I can reuse work I've done. In cases where, okay, now we need to implement a new version of this library because it's a different code base or in a different version of the same framework or something like that, you just have to do the legwork on that. And you have to choose the most, what's the word? The most valuable applications to do this on. Sure.
So I think maybe you just answered my question, but it was a little unclear if you were pulling on a regular schedule and then running the tool, or if you were blocking on the merge request, or if you were pushing for them to run the tool in the IDE.
I don't do the IDE one, but the other two I do. So I have not had a lot of luck with the IDE method because it just ended up too many projects and too many weird some people are using Sublime, some people are using Visual Studio, et cetera, right? And it rather gets annoying writing a plugin for everything. But I have found a lot of success on pull requests, so that I highly recommend. You just scan their diff. You don't scan like everything in their PR, but just the diff, or every file in their PR. And then scanning on a regular cadence. I have a kind of timer that I just do this on a weekly basis, and I just get, Monday morning this is a weird thing, and I might talk about this in a separate talk, but ultimately I do get me a git commit from a week ago, run the scan because it's fast enough to do that. I do this, it automatically happens at Sunday morning. I don't even check until Monday. Do the scan on a git commit a week ago, and then do the scan on a git commit now, and then do the diff of that output of the tool, and then I have all the new bad for that week. And that gives me like a good thing to start on Monday morning. Sure.
In the world of dynamic languages where you can sometimes do frightening things with monkey patching and whatnot, where do you find to be a useful place for those types of tooling? Do you ever try and, add logs every time someone calls the unsecure MD5 thing by rewriting a thing? Or is there a point where you're like, yeah, no, just stick with the static stuff because it doesn't have side effects?
Gotcha. So he asked with dynamic languages, some like Ruby, Python, JavaScript. Even with dynamic languages, you do write the code before you ship it, thankfully. So you do get to see the code and you do get to see the pattern. So the example of open redirects, if it's in like in an Node.js app, I can think of, essentially most of them will have the pattern res.redirect or response.redirect. So why I like, instead of using like a full thing like ESLint or like more complicated static analysis tools, just using supergrep or DevSkim or whatever, right, or grep, is it doesn't need to be able to parse the code and it doesn't need to be able to compile it because, hell, sometimes you can't compile it. It just, for some reason, requires ridiculous configurations or it's a dynamic language, so you don't compile it. So why I like that is that helps in that case, but then again, it's a dynamic language, so who knows what it does.
And I think that's time. Thank you.
Cool. Thank you all.